Hello and welcome to the video lecture series on Introduction to Computer Networks. And today's topic is going to be on wide area networks or WANs. So what are wide area networks? We know that LANs span a single building, a small campus, or a small network setup. However, on the other hand, WANs, they can span even across multiple cities, countries, and even continents. So they are very large networks and they cover a very large geographical area. So basically the primary difference between LANs and WANs is in terms of the scalability and the operational size of the network. One of the best examples of a WAN, that is a wide area network, is today's internet. So if you look at a very simplified structure of the WAN network, it looks like a connected network of multiple LANs together. And moreover, the WAN actually is able to connect not only Ethernet LANs, but also many different other kinds of smaller networks together to be able to communicate with each other. So in this case, for example, we have an internet service provider providing a small LAN setup. On the other hand, we can have traditional phone service providers, that is, the PSTN network, and it could be a network of telephones through DSL modems or something else. We could have the telco service provider, which is more of the traditional or the older form of networking providers. So the telco service providers, they could provide a network as well. And finally, you may also have cable service providers providing the connectivity through cable modems, for example, for TVs and cable phone, etc. So this is a different kind of network. So all of these networks together could be bridged with the help of a WAN, that is a wide area network, and the wide area network itself has its own set of core routers. And if you see here, there are certain WAN switches and routers which are connected to the external networks. So we call these edge routers or edge switches, and then you have the other kind, which are the core routers, which are not connected to anything which is external to the WAN network. So WAN service providers could be many different types. We generally classify them as ISPs or internet service providers, telco providers, traditional phone operators, cable operators. However, traditionally WAN providers are referred to as telco operators or telecommunication operators. The short is telco. And all of them, they connect the WAN network to the customer side through something that we call the local loop. So basically the local loop is the connection which connects the customer side to the provider network. And what we refer to the customer side is that it may include the local network, which is the LAN, or it could be a cable network such as broadband internet or cable TV, etc. And these networks needs to be connected through to each other through the networking of the WAN. So if you'd like to get a quick idea of the evolution of telco networks, so early telco networks, they were connected, they would connect to the customer networks or the customer sites through local loops. So the local loop is this part which would connect the telco to the customer sites. The customer sites would need to have something that we call analog digital converter. So the analog digital converter would would help traditional phone systems or networking devices such as routers to interface with the analog digital converter and eventually connect to the telco network. Another thing which we will look at a bit more details in the later slides is that the earlier version of the telco networks were based on circuit switched connections. However, modern telco networks, they are more like ISPs, but they are just larger ISPs. And instead of using what we used to call the local loop, they would now use routers to connect to the telco network. And they have what we call the digital leased line. So that means a customer would basically rent a physical cable or a connection from the telco to the customer side to be able to connect to each other. And in the modern version, instead of using circuit switched like the older telco networks, the modern telco networks use more commonly the packet switched connections, something that we'll look at a bit more in details as well. So if you're looking at how the WAN operates with respect to the networking model, we have looked at the OSI model, which has 7 layers, as well as the TCP/IP model, the newer version, which has 5 layers. The WAN operates with its WAN-specific protocols in the data link layer, and there are WAN-specific hardware, cables, connectors, etc., which work in the physical layer. So WAN protocol would need the support of both the link and the physical layer together to function. So let's look at a very simplified form of the different topologies which allow the setup of wide area networks. So the most simple kind would be a point-to-point network where each of the routers are connected to each other. And they are connected directly, so there isn't any centralized device, and all of them can speak to each other with one direct cable connecting the two endpoints. The connections use full duplex, which means that both the ends can send and receive at the same time. However, if you look at the way that the point-to-point network is set up, it's comparatively expensive given the amount of cabling that is required to set a point-to-point network. Examples of it could use leased lines or leased circuits, etc., but it's not required that it would use any of these. Just the specific topology requires a point-to-point network to be connected directly to each other. So moving forward, a bit more efficient in terms of the setup and slightly cheaper than the point-to-point network is the hub and spoke. In this case, we have many routers which are connected to one single router in the middle. So what eventually happens is that the routers which are on the edges, they interface with the outside network, and inside they all connect to a single router, and this uses much less cabling than point-to-point networks, and therefore it's considerably cheaper. And the way the frames are traveling through the WAN network would require it to travel over multiple WAN segments. This is different than point-to-point where everything was a direct communication. And finally, the more modern form of WAN topologies is what we call multi-point. And in this, we have a core WAN network and an external point WAN network. And we see that the internal core has connections which is abstracted from the outside. So we may have multiple sites which connect to what we call the provider edge, and inside the routers may be connected through one or more multiple links. So this is very commonly found with packet switched WANs, and they don't really have the necessity to use long leased lines inside the WAN network. So if you compare the three versions, the multi-point is probably the cheapest to set up, and it abstracts the way that it is operating inside the WAN with respect to how a customer is connecting to the WAN.